So here's yet another week of us talking about stuff. And if you're new or you haven't paid attention, if you look down below the video in the description on the YouTube videos, there are various links. And one link is to the index of what we've done for the last 3 years on this channel. And if there's another link that takes you back to the ROS agriculture stuff, which was like 3 years before that. So we've got lots of stuff archived here. And if you want, before you watch this video, go look at the index and say, is there anything there that catches your interest? If not, you can just pass it up. Or if you want to go back and pull up the index and then later on, look up, say, GPS or look up encoders or whatever you want, you can search through that and then pull up the videos and watch those. So I found that I was just using that today and found that very handy. I was looking up stuff on a Systron Donner automotive gyroscope, and I found two or three videos where we're talking about that. So that was handy. I found that out in the ROS agriculture stuff. So anyway, that's just FYI. So one of the things we were talking about, or last week, I said something about adding optical isolation to something, and Al said, "Well, which chips are you using on that?" And I couldn't remember what they were, so I did some digging, and here's a board that was let's see, this is all backwards. So right here, these empty sockets, these are for what they call PIC servos. And a PIC servo is some guy took a microchip processor chip and programmed it to be a motor controller. And then on here, down the middle here, the white chips are opto isolators. They're dual channel opto isolators. And there are a couple of empty sockets in the middle. I don't remember what those are for. And there are some other logic chips there. But basically, this forms a complete dual channel motor controller system. So you talk to it over a serial port, and it's optically isolated and then hooks to these connectors. These are for the old open source motor controller boards. That was a group effort on the internet where people designed these motor drivers. They claim they do 169 amps or something like that. And I only bought one set of MOSFETs. Mine were probably good for 20 amps. And basically, so also on this board, these red connectors, these are the encoder inputs. So you got a motor with a big motor. This connector connects to the power driver board, and then you got your big motor out here, and then the encoder coming back plugs into these two red connectors there. And that was the culmination of trying to get those chips, because I really like those controller chips. And then here was an intermediate version where this is basically the same. This is the opto isolation part of it. So you had a cable coming in, say, from this one, comes from the controller, and then it goes through the two opto isolator chips, and there's some kind of a logic chip, and then I've got a 5-volt regulator, so it would pick up the 5 volts from the power driver board, and then that's what would power that side of the opto isolator. So that was a way to give me two channels. No, actually, that was four signals. It was actually opto isolating 4 channels coming in from this cable through these two chips, and then coming out on this cable. You had the 4 signals, same 4 signals, but they're optically isolated. And it turns out these chips are, I think it's a TLP 2630. And that didn't mean a whole lot to me. So when I pulled it up on Amazon, I was noticing that some of the description was saying this is a dual 6N 137. And also either the 6N 137 or the TLP 2630 was saying these are good for 10 megabaud. So that means these are high-speed chips, and you don't have the problem of pushing a square wave through and have it rounding it off into a sine wave or into round. It trims it off into nothing if you try to run too high a frequency through it. So that gives me indication this is something I built and it worked. And this is pushing like a 20 kHz square wave through the PWM channels, and it seemed to work great. So I'm going to say either of these two opto isolators should work. And also when I was digging, I ran across these boards that I made one time. So basically I took this stuff and made a printed circuit board out of it. And I see there's actually less stuff on the little board. It doesn't have the big logic chip on there, but there is a 5-volt regulator on there. So this can be powered from the destination. And I'm guessing these are the same as white chips, the TLP 2630. I think I just simply put them on a printed circuit board. And again, how do you get this to focus? It probably won't, but anyway, these are boards I made, and you can see I got a whole stack of them here. I think I would go look through my box of boards. I think I ordered like 50 of these or something one time, so that might be a handy thing to just be able to put in between. See, I'm going to hold up anything here. I'll leave my background turned off for a while here. What was I saying? I was looking on Amazon. I forgot what I was saying. So anyway, it'd be handy to have something like this. You just unplug the wires and plug them into a board like this and be able to optically isolate it if it turns out to be a problem. Now, I guess my theory is, in general, if you put all the stuff together and everything works just fine, then don't worry about it. But if you run into a problem where you start having weird resets and just bad, like an analog channels might have extra weird noise you don't want, so it might help to be able to optically isolate this stuff and take care of some of that stuff. And then, so while I was at it yesterday, I was digging through Amazon, and I found like 10 of the 6N137 chips for, I don't know, $6 or something. I ordered that, and then I ordered I found two other little opto isolator boards. So there was a single channel board that has a fairly slow opto isolator on it. So I ordered several of those just to play with. And then I ordered another board that's got 4 channels on that board, and no indication of how fast the chip is or what results you would get. So that one, I'm just gonna have to take it out of the bag and hook it up and push some signals through it and see what they look like, because that would be a fairly handy thing. That was like another $3 board, but it had 4 channels. It actually has like header pins on it. So you can just unplug your wires between 2 things and plug them into the header wires to isolate the thing. And as far as the speed, if you're doing something really slow, you're just watching a switch or running a relay or whatever, you turn it on and it stays on, turn it off, it stays off. It doesn't matter how fast the opto isolator is, but as you start running, say, a PWM signal through, if you run a 1 kHz PWM through it, it might work just fine. But your motors are going to squeal. So you run up the frequency, you get up to, say, 20 kHz, and now you have to have some fairly decent converters on there, so you get nice sharp rise time and fall time to make that work. So it's just a lot of it just from experience, you learn that some things work, some things don't. And since I've built these up before and they work, I think the ones I have on order and the ones I have here on my table should work. But I'll see if I can get around and test that out and see if I can make that work. And I think this was before we started recording. The whole point is a lot of the stuff you end up with ground loops, where you have they tell you when you wire up your system, you should have everything should be a single point ground. So if you got this board that has power and ground, and you got this board that has power and ground, you should run the grounds from those all back to a single point and hook it right to your battery. But it turns out that I don't have all my toys in front of me here. Well, here's just as a prop. Here's one of the giant RC servos that has they're put out an incredible amount of torque, and they have these two leads go to your battery. It's like it'll run on 12 to 24 volts is what they tell you. And then it turns out on the board it's got over here somewhere these pins. You can plug a cable in to run your little RC control. So if you got one of these little boxes like this, you can just take a jumper wire from there and plug it into here and make the thing run. But the problem is over here on the 3 pins, one of them is a ground pin. Well, the ground pin there is tied directly to the ground pin that goes back to your battery. So once you install this device connects your logic ground to your high power ground all right on this module. And if you have 2 of these modules, you got 2 places that's happening. And if you're running the power drivers like the Citron, like 10 amp single channel or 10 amp dual channel or the 30 amp single channel, those all do the same thing again, where they've got the big power leads coming in, and those go to your battery, and then they've got some kind of like a logic interface, and those is tying the grounds together. So now if you've got, say, in my case, I've got one of these and I've got that Citron board, both of those are doing that to you. And probably if you put in a switching converter, you're going to tie that to the battery on one side, and then coming off the other side, that's the same ground that's going to the battery. So eventually you're going to run into problems with all, trying to connect all this stuff together. And that's the whole concept of optically isolating everything is a way to get around problems that may be caused by that. But back to the point, if you hook it all up and everything works great, I'm going to say don't worry about it. But if you start having weird problems, again, noise on your analog signals or your processor just randomly resets due to various conditions, then you might want to look into optically isolated stuff. And I'll try to come up with a little better description of this, and actually show. Yeah, when I get these chips, I could put on the oscilloscope and run signals through and show what the resulting waveforms look like. And then if I build up one of these boards, then I could just say, just unplug the wires from here and plug this in, and that will take care of isolating that stuff. So, and I'm sure if you look on YouTube, there's probably lots of people talking about this stuff. Usually I thought I'd go to YouTube and find out, how do I find a fast, high speed A to D or opto isolator? And when I look, everybody is actually saying, oh, here's how you test it with a voltmeter. So they just want to say, if you turn on the LED, you should see the output level should change. But that has nothing to do with frequency. That just simply, does it work or not? There seem to be hundreds of videos of saying, here's how you test it in a static condition. But that's not what I wanted to know. I want to know, how do you find a fast converter that will do the job? And so it came back to me just digging through my junk box. So I found these boards. I held that one up, right? Yeah, so I held that one up, and that was essentially, this is something I started with, and then eventually when I made this one, I just have the two controller chips here, and then all of the logic and isolation to do the whole thing. So this would connect directly to the flat cable from here, would go out to a motor driver board, and then the encoders came back in through those red connectors there. So this would give me a way to control two motors, and these chips worked really well for that. So I think I've pretty much beat that to death. I've got some of those the small chips that it's like a 4-pin chip. And I think that's the ones that somewhere they say, yeah, maybe they're good for 4K hertz. And I got a bag of them somewhere that I can put those on the proto board and test them. But one of those boards that I just ordered from Amazon has one of those chips on it. And I can, I think it's got terminal strips on both ends. So it's, fairly easy to hook up. But again, I can put that on the scope and say, if we put this frequency through it, what does it look like when it comes out the other end? So that's things I could play with.
Show the back of your bigger board so people can see how complex the soldering job was.
Well, this is when you got a lot of chips, a lot of connections, you just simply end up with a lot of wires. And as I was pointing out before, this board has a pattern where it's got strips across it, so it's got 3 holes that are connected together, and that makes it easier for soldering, especially if you're using big wire like I'm using. It's like 22 gauge wire, and I've got older boards where I use wire wrap wire, so it's like 30 gauge wire, and a lot of them are just the single pin. So if you've got a board, a board like this that's just got the individual, they're all single pins on there. And again, this is the one, it's got pads on both sides, and they're plated through. So this is a really nice board to work with, but it makes it harder to hook up. Say in this case over here, we're looking at this, and I saw there's one right there. There's actually 2 wires soldered down to one pad, and you can put multiple ones on there if you're patient and you don't mind that you heat it up and have wires popping off. That's a way to do it. Or you could actually put come in through the top and put the plug the wire in through the top, like these are done. So you see the orange wires on there. and they simply, you stick them through the hole and then flip it over and solder them down. So that's a way to do it. But eventually you need to start running long wires, so you just end up doing this kind of stuff to it. And if I dig far enough, I've got a I think it's a dual proto board that has two of the controller chips, and it's got a lot of other stuff on it, and it's just a big rat's nest of wires plugged in the top of the proto board. It's got at least that many wires, and probably more, sticking up above the top of everything. So, digging through my archives, I've got all kinds of stuff like that I have collected, and in this case, it was handy for a reference because I can go back and look and say, oh, these are the kind of parts that I need, and I know this worked because I was using this at one point.
Very impressive.
So the other thing, I was talking about wiring, and I showed that my robot last week, that the small robot, it's just got a piece of perf board, like this this type of perf board is actually a little bit smaller than this, screwed down to the top of it, and I was just going to put just any random controller, put on the board, and then I was saying I could just solder like header strips over here, and then on the back do this kind of wiring on the back to hook it up. So you just take wires from the and, and if you put this processor into a socket, and you can buy those like header strips, but they're sockets opposed to pins. You just cut them off the length you want, you solder them down, and then you can just plug this board right in. You just plug the board into those connectors. So if you burn up the board, you just grab it, like, pop it off and throw it in the trash, and then you just take another board and plug back into the socket, which I don't have a socket on here right now. This just for reference, that, so you plug in a new chip, so then you just have the wires soldered on the back on the socket pins over to your header pins, which maybe would go over here. So that's what I was planning on doing. But that got me thinking about all the almost infinite variations on how to do this. So that's one of the variations right there. I've got some kind of a controller module, and then I just solder down connector pins on the board and wire those together. So then if I got coming up from my encoder, which right now, this is the type of encoder that I've got on the back wheels of my Sammy robot, and it just simply has what they call flying leads. So it's got the wires stripped back, and it's got the four wires sticking out, and they just happen to be they're stranded wires, which makes the cable very flexible, which is good at times to have that. But you really can't take those and shove them into a proto board, because it's going to complain. They are tinned, but that don't rely on that. So what I would do is I take this kind of wire, which is solid wire. It's insulated, it's tinned, and I bought like a 1,000. It was a 5,000 foot roll, but it was partially empty. So I got like 1,000 feet of this kind of wire, and I use it for everything. But what you can do is you cut off a little short piece, cut off like an inch to inch and a half, and then just twist this lead onto the end and solder it, and then put heat shrink over that. That basically just forms a plug that works really well to plug into, say, if I want to plug into this proto board, see, I can just plug the orange wires in any hole there I want. So that's one way to do that, where you can get these kind of, jumper leads. And simply, you buy the jumpers, you just, what I do, I just cut them in half, and that way it gives me a piece of wire with a colored wire and whatever connector I want at the end of it. And again, just solder that onto the end of this. And somewhere I've got examples of all this stuff, but they're not in front of me right now. And so that's why you can either do this way. You can put on the male pins or the female pins. And was there another option on that? That's it. Anyway, I'm just saying, take whatever connector you want, put on the end. You can also get like crimp on connectors, that like a 4-pin connector. So you put all these wires together and you crimp them on, and that thing would plug onto header pins. So that's another option on that. So if you don't want to do them a single wire at a time, you can get a plastic block that's got the pins in, and you plug onto it, just to make it easier to install and uninstall the stuff if you need to, say, take the board out to work on it. And then there's other options of, I was thinking that I could have, say, a small board with connectors soldered on it, and then I could just run orange wires out, put about 6 inches of wire in each one. So I've got this board with a bunch of wires hanging out, and it's got connectors soldered down. And then the other end of the orange wires simply either on a proto board, I can just then plug those into a proto board, and I could do it that way, or I could do this where the thing is actually soldered down to a board and then just solder the orange wires directly to the socket on the back. Or you could have a big connector and run all the pins of that connector and run like a flat cable over to a board like this. So that again, I kept coming to more and more thoughts on how you could do this stuff, and I was trying to decide there's various things like what's easiest, what's cheapest, what's quickest, and then based on all that, what's going to get you into trouble the quickest, because you're going to end up with something, you're going to end up with a mess if you're not careful about what you're doing. Oh, so it's laying right here. Here's another concept where you get header pins. These I think are the long ones, and so you can buy them. Normally you get header pins they're short on one end and long on the other. So you put the short end into your board and solder that down. But you can buy ones it's got the long piece on both sides. So I can now put that. In this case, I had it plugged into a proto board like that, so the pins are long enough that they'll go down in and make connection. And then you still have the wire sticking up. You can put the plug those kind of jumpers like these, so you can plug these onto them, and that works. So that way, if you put these kind of connectors on whatever you're doing and you want to plug it into a proto board, you can just use something like this as an adapter to convert from a hole in the board to a pin sticking up. So that's more things to think about right there. And there was, I think, some other variations I had on that, but I'd have to actually, number one, walk around the house and find things that are hooked up, and then take pictures of them so I can say, now here's an example of what I'm talking about. So that let me just say, I was thinking about all this stuff, and that's what kept me from actually building it and doing it, because I kept thinking of all these different options on how to do it. So that kind of distracted me there. But it does tell me that, yeah, it'd be good to put all the stuff together in one spot and say, here, go watch this video, or go look at this web page to see all these different options on there. So that's all I'm going to say about that, is that I need to figure that stuff out, and I need to get some stuff wired up to try it. So that's kind of where I'm at right now on that.
Anything else to go through?
No, I don't think I have anything.
I suffer from some of the same perplexing questions. I'll just start with this is one of the things that I've been putzing around with the last week or so, and it's an NRF radio instead of the LoRa that I used before. And I'll just should have pulled this out before, and instead of taking it off the board, it comes with the 8-pin connector. I don't know how well you can see that. And so in that case, I've got I took some of those, the female headers, and soldered them onto the board, and then was able to just plug in that radio. So that I wasn't looking forward to that. And because I'm not the world's best soldering guy, but I ended up making it work, and I connected it to the Teensy 3.2. Could probably make that a little bit bigger, I think, maybe. And it was interesting. You showed one of those proto boards that had three holes per pad, and that would have probably that's nice. It gives you that real estate, because I was putting this on one hole per, or one pad per hole, deal. And for me to get whatever there is there, 6 or 7 wires connected is just a little challenging soldering job for me. But so I ended up getting it working and decided that these were going to be my pin connections. I'm not sure if it will all work the way that it's because ultimately I'm going to try to use a Teensy 4.1, and I need to do a good inventory of all of the pins and which ones I'm going to use and not use to make sure I'm not creating too many conflicts. But that was what I got working, and this is just the simple hello world script that's running, and it's with this is the low power mode, so I've got it set at the lowest power, and I set it at, but you can hope maybe see that 16 or 17 messages come across in 5 seconds. So I think I set it for 5 hertz, 5 hertz or 3 hertz. 3 hertz, about 3 hertz. And so that's working nicely because, as I mentioned in Slack, for my radio control of the tractor, I'm sending 18 bytes over and I'm getting 17 bytes back. So it's a relatively small package of information, but so I need to do a little more testing, and I'll do some send and receives using this structure. And this library seems to have some like you send it and you get back a notification that it was received, which is nice. I don't know if I ever found that in the LoRa setup. So it's just some interesting testing that I'm trying to make work out with these cheap radio units. One thing that a lot of people, not a lot, but some people mentioned is to connect a capacitor between the ground and power to try to smooth out the power, because these boards are 3.3 volts and the radio operates on 3.3 volts too, but it wants a stable 3.3 volts. So see if that works well. Anyway, talking about connectors real quick, I also, what is this unit? This is a JRK power controller, and I use those, I don't know what those terminal blocks that'll take. And this one, it was just a little bit easier I needed to have 2 boards, and so I needed to connect them. So I put a terminal block to run 3 wires between the 2 of them. And in that instance, going back to Slack, I was just testing out this linear actuator fed into the motor controller, and again trying to drive it off the Teensy, and yeah, that worked. So it had been a long time since I'd used a JRK motor controller, and this might be too small of one, so I need to do more testing to see if I pull 40 pounds or so, put 40 pounds of pressure on this. I'm hoping it'll draw less than 5 amps, but we'll see it, because this is only rated up to like 6 amps, because the power is actually going through this board as well as the feedback. So a little bit more testing to do there. So that's what I've been working on. That's it for me today.
So that linear actuator, is that the one that has the built-in feedback or
Mm.
not?
Yeah, you have an analog signal that comes out. It gives you, 0 to 5 volts, but the JRK handles all of that. And I just give it a UART command. Let's see if I'll pull the code up here. Share. But yes, it gives you the feedback, and you're able to read that from the teensy in a digital mode. Dag nabbit, where's the share button? There it is. You can get if you there's the command. You can request feedback. Gives it in a slightly different range, but you can get that after and it comes back in a digital format. But technically, it's from the linear actuator to the JRK board. It's just a 0 to 5 analog voltage.
So the way the board works, it automatically, you just say go to position 33 and it does, or
Mhm.
so
Once you get it configured.
okay. My only experience with trying to use those linear actuators with the feedback is that the PWM I was sending to the motor generated enough noise into the analog that it wasn't usable. And I later decided if I'd go to a faster PWM frequency, that probably would make the interference less, or at least be easier to filter out if I was running the PWM at the higher frequency. So yours is probably fixed on, it probably runs at whatever frequency it wants to. So
Yeah, all of that stuff is a bit abstracted for me. I just say go to position 500. I mean, that's then broken down into where's it's broken down into an upper and lower byte. They've got a couple of different formats, but the format that I chose is this more simple format. I say go to a target like 500 and it does it. Um, Now they've got some Windows software that you have to use to sort of figure out what's your lower and upper range. And you have to set a PID using the configuration software. But once you've done that, you say go to 500 and it does. Now, in an environment where there's a motor, a big motor running and there's, maybe noise on some of these signals, it'll be interesting to see how robust this is. But on the desk, it works.
you know what the model number of that controller is?
It's a JRK 21. Oh, well, they've had some version changes. I can put it in the chat, but they have an old style and a G2 style. I think on the G2 they've added some more input modes. But this is a 21V3, which is indicative of how many amps it will handle. And so again, I think this one tops out at 6, probably better at 5. But it also, an interesting thing about this particular controller, although I haven't tried to use it, it will input frequency. And supposedly, if you input frequency, you can control this, the rotational speed of a motor as opposed to just position. So yeah, pretty versatile little motor controller. Not cheap, but versatile.
And speaking of Pololu and motor controllers, when they have their Black Friday special, Black Friday something Monday, whatever they call that, they usually mark some of the controllers. They mark them down significantly.
Oh,
So
that's a good tip.
so it's worth checking their stuff out.
Pro tip.
They have all,
I didn't.
they have all kinds of weird little games they play, but still, if you dig through it, I got a whole stack of little controller boards from them that I've never done anything with, but they seem to be significantly marked down. So I bought a bunch of them. And
Yeah, I have a few. I have a few drawers full of stuff like that. I know I'm going to need this sometime.
yep. And speaking of, and since Black Friday's coming up, since Thanksgiving is the end of this month, that's so you start thinking ahead. And I know like Servo City runs that, and there's lots of people that online will have special deals on this stuff. And
RG Simple, I think, had that had specials too, like that.
yeah,
I don't need any more GPS units, though. Thank you very much.
that drawer is full now.
Yeah, full enough. Anyway, so that's I'm just sort of thinking through a sort of a new approach to my electronics board and trying to figure out how I'm going to hook all this stuff up. Good for the recording for today.
When you go to install that linear actuator, um, you plan on putting the controller close to the actuator, or are you can leave the full bundle of cable laying there? The point is, you know, if you were to cut that cable off at a shorter length, if you do have problems with noise on the thing, you could cut that off to a shorter length to put the controller close to it. Or simply, if you're going to run it somewhere else, put the controller up in your electronics box. Just make sure you don't run that wire, next to any like high power, like the battery leads or something, because that's going to generate, don't run high power leads next to low power leads in parallel. Don't strap them together and tape them all together, because if you've got, say, your big power leads are generating enough noise to cause a problem, just by strapping your like analog leads against that, you're going to pick up all that noise. So it's just a matter of when you go to lay it out, keep the wires physically separate when you do that.
Yeah, so thanks for that. The first thought is the electronics would be in the electronics box, and so I would use that length, or let's just say it might be 18 inches of cable running from the electronics box to where the linear actuator was mounted. So I don't, that's part of my reason for being interested in the opto isolator is, would I have to use one on that signal line, but we'll cross that bridge when we come to it, I guess.
So as a related anecdote, I worked at a place where they're building this big equipment, and they would the people would say, okay, we're going to have these giant um, motors. They're like three-phase motors, and they put them out where they need them. They run all these cables back to the main controller box, and then they also had like video cameras on the thing, and they'd run their video cables. They run all these cables in the same cable trough all the way back. So when they get it all done, they'd fire it up, and the screen would just be unreadable. It'd just go, and you keep telling these people, don't do that. Separate the cables out, and oh no, wait, that's where we're going to do it. Okay, fine. So there was that, and they were reading like load cells to measure weight of something, and that's just out at the end you've got the like, what are the resistive, some kind of resistive load cell, and then they had like 50 feet of wire that would run through the cable racks to a box on their controller box, and those the weight was almost unusable on that too, because they had purposely bundled all their wires together, and that's not the thing to do. Now, if they
There's
would have
a,
had like two separate cable racks, put all the high power stuff in one and put all their low level stuff in another one, then they probably wouldn't have had those problems. But every time they build a machine, it would do that. And so, oh, well, maybe you can just ignore that. Maybe you can filter it out. Yeah, maybe you can just not do that in the first place. But so that kind of thing comes up. And
some junior engineer who was learning about the practical realities of actual implementations.
no, these were senior engineers. They've done it this way their entire life. But we've always done it that way. Yeah, I know. And it's never worked. So and yeah, but as you say, you learn from experience and you see the stuff happening, and yeah, it's very obvious once you go to do it, and oh, it doesn't work, and then you can go figure out why, and then try separating your wires out, or like I was talking about the ground loops and all the weird grounding, you might have to look into that eventually. So, if you have problems.
Yeah, controlling speed has been a challenge. So we're going on a new journey here with this linear actuator.
Well, another thing I've been thinking about was, since I'm playing with the new encoders on this thing, I got the ones strapped up here, and then I've got the original ones on the axle. And I was, you were talking about if you're driving around on GPS and your GPS drops out, you want to back off to some kind of wheel odometry. And I was thinking that my experience with wheel odometry is that if you're trying to get the distance or the speed from this thing, that's usually fairly accurate. So as you're driving along, it tells you, how far you've gone, and that seems to all work. But the heading that you get off the odometry is not quite as it doesn't work quite as well. It doesn't work as well as expected. And I was thinking, well, what you could do is you could take the distance from your wheels, so from the wheel odometry, and then take a heading from somewhere else. If you have an IMU that you mostly trust, you could combine the heading from that with the distance from the wheels and generate an odometry statement from that. And that's kind of why I was digging through. I don't know if I mentioned this, but I was digging through and ran across that industrial gyroscope, or as an automotive grade gyroscope that I had one time. And I was just speaking to the index stuff. I was going back through ROS agriculture and found where I was talking about that. And I was thinking that might be worth putting on, because that seems to give me a more stable heading than what I get off the IMU. The IMU is corrected because it's got the magnetometer, but this thing, the automotive one doesn't seem to drift like all the little cheap MEMS ones do. So anyway, that's something I was thinking about, that combining different sensors together. And I think that's what if you run the robot localization, which has the fancy Kalman filters in it, and you feed all the stuff together, I think it's somehow magically doing that for you anyway. So you can say, I want to take my distance from my wheels, and I want to take the GPS stuff into it. I want to take the IMU stuff, take whatever pieces off the IMU you want, and then the filter, tries to merge all that together and come up with a reasonable answer for you. But I haven't played with that localization, that robot localization. I know other people use it, and I know when I was working at Danfoss, they put that on there, and then they drive around, they come back, look at the plots, oh, look, it's converging, and they came, it's converging. And I wasn't quite sure what they were looking at, but they seem to be happier with that than not doing that. And I think that's what all the real robot people do, is they throw that kind of stuff at it, and apparently they make it work. So that's just one more thing to think about, that possibly you could merge different sensors together to make this work. And at the same time, if see on mine, if I've got code that's taking the back wheels and converting the odometry, which gives me my distance and my heading off from that, and then in parallel, I can still take the distance from that and feed it in with, say, an IMU. So I'm generating two in parallel, so you can see what they're. If nothing else, you can compare them to make sure nothing's gone really bad on you. But that might be a reasonable way to do that. So that's just something else to put on my list of things I'm never going to do.
Well, even though you might not do it, it would be interesting to see what it would pull it out maybe for next week. What's the gyroscope sensor that you've found or have access to? Because I haven't messed around with those at all. Other than, the IMU BNO 85 or whatever it is.
I guess that's all I got for this time.
Good deal. That's all I got.